All right, hello everybody. We're back with another stream, but this time we'll be doing something different. So previously we'd done some work related to web development, and I know you all love that, and we love to do that as well. But this time around, we're going to do a small teaser of our upcoming video on GoDot. So there'll be a video on the main channel where I'll be discussing everything that we do in this stream in depth, and we're actually going to build a platformer game over there. However, in today's stream, all I want to do is build a very simple Flappy Bird game for you. So keep in mind, you don't need any assets, any external tools. You just need GoDot engine and then nothing else, just your device and your GoDot engine, preferably a mouse, but if you have touchpad, that's fine. So if you have any questions, you can drop them down in the comment section and I'll be looking at the chat. Hello, I can see your chat. All right, I'll start by playing the game a little bit. So this is how our game looks right now. I know it's very plain, there's not much assets inside it, but you do go through pipes. They are procedurally generated and you can flap your bird. It feels like I'm pretty good at this game. And you have your grounds, you have your pipes, you have your score up top. And if you hit a pipe, it says game over and you can click to restart. Now, if you want, then we can go ahead and in a future stream, we can add some assets to this. So we can create assets for these pipes, maybe have a cleaner ground. And of course, the birds itself will add some animations over there. And we'll clean up the UI in another stream. But in this stream, I'm not going to concern myself with that. We're going pure game logic right here. If you've never coded anything in GoDot before, and if you actually have a great interest in reading, making games and stuff, so this is going to be very useful for you. All right, so I'm going to close this out. This was my demo project that I had for you. Where I'll start is, I think I'll start by actually showing you how to get GoDot. So I have my YouTube right here. Oops, spoilers. I'll open up Chrome. So inside my Google Chrome, let's see. Let's download GoDot. So simply search up GoDot engine. And once you search that up, open up the first link. As soon as you do this, then you want to go ahead and download the latest. Now, you can get the .NET version, but it works with C#. So if you're familiar with C# language, then you can go ahead and use this engine. Personally, I prefer using GDScript, which is GoDot's own programming language, kind of similar to Python. So if you're good at Python, then I recommend you get the GoDot engine. You can go look at the requirements. Everything should be pretty simple. It should run on pretty old machines as well. That's the advantage. It's not heavy like other game engines. But there you go. GoDot is going to start downloading. And what you're going to do is, I'm not going to download this right here. You're going to download this zip and you'll extract it. So once you'll extract it, you'll have these two files. So I won't open up the console version. I'm going to open up the stable Win64 version and you'll see something that looks like this. Now I had Flappy Bird. Let me remove this from my project list so you'll have something that looks exactly like this. Now in Asset Store, you can download a bunch of stuff. You have your assets for a whole bunch of stuff. You have 3D demos, a Pong multiplayer demo. You can build very extensive games in GoDot, and you can actually download some of these assets and then play around, tweak with them as well. So we'll be going from scratch. Now, what is GoDot? GoDot is a game engine. So it is a game engine where you make games, right? It's like Unity, Unreal Engine, but much lighter weight. As you can see, you just download that. There's no installation step, directly opens as an executable. And GoDot employs a language called GDScript. So this GDScript language is actually very similar to Python. And I'm sure a lot of you who are very new to coding and familiar with the Python language will find this very useful. So we'll create a new project right here. Once you click on create new project, you want to give your project name. So I'll just name this Flappy Bird Demo like this. And you can create a folder. I'm going to browse. So I'm going to browse in my D folder. And then I'm going to go to YouTube. I'm going to go to Go.Live. And I had this test folder right here. I'll just select this current folder and it'll build the Flappy Bird demo inside it. So whatever folder you create, it's going to create another folder inside it and place all your files in there. Now you can add version control metadata, but for now, I'm going to keep this as none. For renderer, I think forward plus is pretty fine. So you start with desktop platforms. If you want to build games for mobile games, so for mobile platforms, for Androids, we can go ahead and cover that as well in a future stream or a full course. So I'm going to create this project right here. As soon as I create this project, a window is going to shortly open up. It has opened up on my second screen. Right. In this window, I'm going to go ahead and explain the interface. First and foremost, I'm going to explain the interface. There's a bunch of stuff here. Now, if you're familiar with other game engines, and this, trust me, this is the last time that I'm going to be referencing other game engines, but if you're familiar with those, then you can notice some similarities, right? On the right side, you have your inspector. So anything that you select in your game, it has some properties. It has a size, shape, layers, masking. We'll go through most of these properties. They'll show up on the right side under your inspector. There's a signal section here, which we'll talk about briefly as well. And on the left, you have your scene. So everything that exists physically inside your game is going to exist in a list format on your screen. Right below it, you have your file system. So this is the actual project folder that we have. So inside the project folder, we have a res folder with icon.svg. This is just your GoDot icon. And you can see if I double click on this in the inspector, it actually shows the properties of that file. And it's the same with any other asset inside GoDot. Now, what do we do first? Well, first of all, in this game, we need the actual bird, right? We can start with a bunch of stuff, but I'm going to start with the bird. But before that, if we start right now, we don't have a scene right now, but you can see this blue border in the middle of the screen. Yeah, that's how big your screen is going to be. But for Flappy Bird, you kind of want your screen to be a bit smaller, maybe like a portrait view. So we're going to go ahead to project, under project settings, and you'll see display. On the display, click on window and you can change the viewport width and the viewport height. Now you can drag this around, but I'd like to give you specific values. The width is going to be 480 pixels and then the height is going to be 720 pixels. And down here in your aspect, I want you to keep this on keep. If keep is kind of buggy for you, you can change this to expand. That's all we need to do. You can close this up. And now you'll see that your editor immediately changes to this portrait view. Now, if you're wondering how I drag right now, just hold down space. As soon as you hold down space, you'll see that my cursor turns into a move tool. And when you're holding down space, you can move your screen around like this. You can scroll in and out, and you can hold down space and move around. This will be the primary way I will change any elements in this game or move around this editor, holding down space. Now, there's a 3D version. You can create 3D games in GoDot, and it is pretty fun to create 3D games as well. But in this section or in this tutorial, we're just going to be looking at 2D games. All right. So there's a bunch of stuff that I'll be going over as we build this game. And the first thing, after we're done with changing our viewport, I'm going to create some files for organization. So first of all, I'll create a scripts folder that is going to host all of our scripts inside of it. And then I'm going to create another folder called scenes, which is going to have all of our scenes inside it. So I'll have to explain what a scene is and what a script is. So scene is, well, literally anything in your game. Like your main game will be a scene, but your player is also a scene. Your enemy will also be a screen, and so will most of your other things inside GoDot. Let me look at the comments. All right. So we're going to start by creating the scene for our player. We're going to create a player, basically. Now, there's a couple ways you can start a scene. You can either start it using a 2D scene right here. Or you can start a scene by adding another node. Now, I introduced another word there called node. What is a node? Well, any scene is made up of different nodes. Different nodes make up a scene, and multiple scenes together make up a game. You'll get used to this terminology and this way of creating your games once you do more GoDot engine stuff. So I'm going to start by creating with another node. Now I can click another node right here, and I will start with an area 2D. You have multiple nodes. You can scroll through all of this and then look at all the nodes you have, but I'll start with area 2D. And, well, nothing happens. Well, this is because it's just an area. It doesn't have a shape. The area 2D right here, we can rename this to bird. Now, what is an area 2D? It is just an area. But we don't see an area on the screen, do we? You can zoom in. And you'll see that it's just this little node right here that's called bird. Well, that's because we haven't given it an area yet. We're going to give it an area by adding a polygon 2D. So you can either right click and add a child node. You can click over here and add a child node, or you can press Ctrl A, which is my favorite shortcut in GoDot. Hold on. Which is my favorite shortcut in GoDot. Just press Ctrl A. And you'll bring up this create new node. It's basically the same thing, but just a small shortcut for you right there. So anytime this window pops up, assume that I press Ctrl A. And we're going to add a polygon 2D. Right? As soon as we add our polygon 2D, it is now a child of our bird. But you can still see that the polygon doesn't really have a shape. That's because we need to draw it. Now come into your game right here, and then just click and then start drawing. Now, I'll just draw a small shape for a bird like I did before. It might just be something like this. And I'll complete the shape. So this is my bird. Now your bird might look different. You might draw a different bird. If you don't like it, you can redraw this bird so you can cancel out the points. You can remove the vertices, and then you can create a new polygon. But I like this pretty much. You can change the size as well. I think I'll make it slightly bigger. And the positioning really doesn't matter because this isn't our actual game scene. Our actual game scene is going to be another one. This is just for our bird. We can just purely work with our bird right in here. Let's change the color of our bird. We want ideally a bright yellowish. Let's see. Yellow that's a little bit brighter maybe. Slightly more yellow. Yeah, I think I like that shape. Now, once we've created our bird, you can see that it looks like it has an outline, but that's just the selection. It has no outline. Once we've done that, now we're going to save this scene. But before we save this scene, we actually need to do something else. Right now, our bird exists, but our bird cannot collide with anything. Actually, I think I'll do the colliders in a bit when I introduce when we need collisions. So for now, let's just save this. Should be pretty simple. Press Ctrl S. It's going to give you the default bird.tscn. That should be fine. Go into scenes and then save this bird. Now, as soon as you save it in here, it'll just appear right here in your file system, and your bird scene is saved. Now you can close this out, and if you double click the scene, you can see that it will still open up. Now, after we've done this, I actually want to write a script for my bird first. And this is our first introduction to GDScript. So I'll click on my bird, not the polygon 2D, the bird itself. And then I'm going to go down on the right here. And then under my script, I'm going to click this button. Wait, not that button. I'm going to click this button and then click on New Script. We'll leave it as default named, but instead of scenes, we'll save it inside our scripts folder because we've made that, and we'll create it. Now there's a bunch of stuff going on in here, and you shouldn't be scared looking at what's going on in here. It's pretty simple actually. This is basically a script that is now attached to my bird. We have two functions that are given to us by default, but right now we're not going to use this ready function. We can just choose to omit this ready function. We will call this process function though. Let's read what it says. Called every frame, Delta is the elapsed time since the previous frame. Okay? So delta can be said how fast our game is running. Right? Since if your computer can run a game at higher frames per second, that means the time elapsed between previous frames will be shorter. If your computer can run a game at lower frames per second, that means delta is going to be smaller. So delta is representative of how fast your computer can generate frames. And this is very useful when controlling speed. And we'll look at that in a bit. But basically, this process, you can see that it is a Python-styled function. You have the func keyword, the function name, the parameters. You have a return type that we don't need to worry about, but you have a colon, and then you have a body that has pass inside it. So basically, Python. And let's not worry about this extends area 2D right now because we're not using any area 2D functions as of this moment. So what does my bird need? And you can see that I opened a script, so I went into the script section. You can go back to your 2D like so. What does my script need? Well, my bird needs a velocity, right? So var velocity equals to 0.0. By default, I don't want my bird to have any velocity anywhere. And in this case, velocity is going to be my position in the horizontal direction, right? Horizontal left to right. Next, I have my gravity. Since gravity never changes in a game, my gravity is going to be a constant. I'm just going to name it const, and I'm going to keep it capital so that we know that this value cannot be changed, right? And let's set the value of gravity to something like 850. Just a pixel count that I threw out there. Next, we need a flap strength, which is also going to be a constant. So flap strength is whenever you press space or whenever you click, your bird has to go up by a little bit before coming down to gravity, right? That is going to be your flap strength. So the higher you set this value, the higher your bird is going to rebound when you click a key. We're going to set this to minus 320. You understand why this has to be negative, because our bird is going upwards, that's going to be negative, downwards is going to be positive. Next, inside our function, we actually need to apply gravity to our bird. So we're going to say simply velocity is going to increase by the rates of our gravity. Now, what you'll notice right here, if we leave it like so, is that on older computers, this is going to be slower because process is called every single frame. And older computers can run lower frames per second. So this is going to be called lower times every second, right? And on faster computers, this is going to be called higher times every second. So faster computers, the gravity is going to be extremely fast. And for extremely slow computers, the gravity is going to be extremely slow. That is exactly why we have delta. Since delta is the elapsed time since previous frame, if you simply multiply this gravity by delta, no matter what kind of computer you have, your frame rates are not going to impact how fast your player, or how fast, in this case, your bird is falling. So anytime you want to make a component inside your game independent of the frame rate, you multiply it by delta. Then my position.y, you can access the position of this bird, specifically this node directly, by simply just referencing its y position. Oops, it looks like I was muted for a bit. So the reason why I use gravity is because hopefully I'm audible. Okay. The reason why I use gravity as capital instead of using your 2D physics directly is, of course, in actual solid 2D games, it would be better if you use 2D physics because you need to do a lot of collisions. You need to move your character around a lot. You need to be colliding with platforms, maybe enemies and such. But in Flappy Bird, you don't really need to be colliding with anything in the traditional sense. Yes, you do need to check for collisions, but those collisions do not dictate your gravity. Like if you collide with a pipe, it doesn't mean that your physics should change. It just means game over right off the bat. So I think it's much more simpler if we implement gravity directly inside our code. You could use 2D physics as well, but I think this is much simpler. And I also wanted to use gravity to directly show you how delta works, since it's a concept that many people who are just getting into game development may not get, the concept of frame rates and frame cycles, the whole game loop idea. This is a pretty solid example when you can directly see that, you can visualize that your player is going to be falling faster for better computers and is going to be falling slower for older computers. I'm sorry I was muted for a little bit there, so I hope we didn't miss anything. Right. And for our position y, our velocity, we added the value of gravity times delta. So every single, frame, we're going to be increasing the value of our velocity by our gravities, acceleration, the whole physics shenanigans. And for our position, we can directly access the position of the node that this script is attached to simply by doing position.y. And once we directly access that position like such, our position like such, we can add our velocity to it. And of course, you have to multiply this value by delta as well, because if you don't multiply it by delta, it defeats the whole point again. I hope I answered your question. I actually answered it a while ago, but it seems like I was muted. That's my bad. I had a little cough in my throat. Let's drink some water. All right. I might drink some water multiple times throughout the stream and go silent for a few seconds, so I hope that doesn't throw you off. And once we've done this, hopefully if we start the game, we should see our bird fall right through the sky. And right now, there's a few ways that you can actually start your game. Hello, Antonis583. And we're making a Flappy Bird game. Hope you follow along. So we can directly start our project simply by going to project settings, and in your application run, you can set the scene that you want to run. But I want you to know a shortcut. You can either press this plus icon on top right here, or you can simply just press F5. And it's going to ask you only for the first time to select a scene. For now, I'll select my current scene. And as soon as the scene loads, you should see your player fall. Your player just falls. That's because this code, what it does is it makes your player fall. Well, that's correct, right? Well, what I want to do now is for the flapping feature. Your player should be able to flap out, flap up. That's the whole point of Flappy Bird. You should be able to flap, right? So for that, I'm going to create another function. Now, it's actually a signal, and I'll get to signals in a bit, but simply create a function like so. For now, we'll just type it out, func underscore input, and we're going to take an event like so. This function. So any function with an underscore, GoDot is automatically going to manage that for us. So you don't need to do anything. Like process, GoDot is automatically going to call it every frame. Underscore input is going to call it every single time there's an input. The IDE is coming with GoDot library. Right, so at the beginning of this stream, you can go ahead and rewind a little bit, but I actually covered the installation of GoDot. So all we did was, I'll go through it briefly one more time for you. We open up Chrome and you can simply just download GoDot Engine. Simply just go to godotengine.org and download this. You'll get a zip file originally. And after you get that zip file, once you extract it, you'll have something like this. And simply open this executable, and you can get right ahead. So you don't have to install anything, you don't have to do anything, you can directly start. And the language that GoDot uses is actually called GDScript. There is an alternative, you can use C# if you want to, but GDScript is much simpler for simpler programming. You know, if you're doing 3D, then maybe it'll be better if you use C# or something like that. All right, and it's much similar to Python. So func input, this is automatically going to be managed. It's going to run every single time an input event is detected by the engine. Every time we give an input, what we're going to check is if event. So if that input event is a input event mouse button. That means we're checking if we're clicking with the mouse button. If we're clicking with the mouse button and event.pressed. So there's event.pressed, event.released, a lot of different types of events, but we're simply checking if our mouse button is being clicked. So the if conditions are pretty simple if you're coming from Python language. And velocity equals to flap strength. Simply all we did was, since flap strength is a negative number in this case, once we click, we set our velocity to this negative number. What's going to happen now? Now our position y is going to update with a negative number times delta. That means we're going to start moving upwards for a bit. But what brings it back down? Yes, the gravity. Since every single frame, we're adding gravity to it, every single frame, we're going to be adding this number to this number. So it's going to go up initially for a bit and then come straight back down. I hope that made sense. Velocity equals to flap strength, so it's going to be negative for a little while. That's going to make it go up. And then it's going to come back down because we're still adding gravity throughout this process. Right. Now, another event is, you can click your mouse button to flap your bird, but you can also press space. And that's actually what a lot of people do. So if your event is a input event key, so every time you want to take inputs from your mouse button, you're going to do input event mouse button. But every time you're going to take inputs from your keyboard, you'll do input event key. And you can check what event key it is. So what mouse button we pressed. Sorry, what keyboard button you pressed. It's going to be event.pressed. So if event is input event key and event.pressed, and to check which one, we're going to do event.keycode. So there's something called a key code, and there are multiple keys, but we're checking for key space like such. You can check for other keys simply by putting in key underscore W, space, up arrow, whatever you'd like to flap your Flappy Bird. Or you couldn't put this check at all. That means any keyboard key that you press is going to flap your bird. Right after this, what we're going to do is now we're going to velocity equals to flap strength. So the same thing. Even when we click the mouse button, we're going to go up. Even when we press the space button, we're going to go up. And that is all, actually. Let's save this up and then let's run this. So I'm going to start flapping. So I'll start by clicking. So you can see whenever I click inside the game, we're flapping. And the motion is actually pretty fluid. Now, since we're using delta time, this motion is not going to be snappy. It's going to be very fluid, going to look very natural. And you'll notice that it almost feels like a Flappy game already, minus the graphics and, well, literally everything else. But the bird is right there. And if I press space, so now I'm pressing space, you can see that it still works. Oops, there's some sirens in the background. I hope that's not too distracting. And we keep going down. But once we go off the screen, there's no game over. There's nothing. There's just that flapping observation that we made. Now, another thing that I want to do right here is I want to add a on body entered. So I'll do this later. I think I'll do this a while later, but basically I'm saying if anything enters my body's region, my bird's body region, so anything entering right here, as soon as that happens, we have to call game over, right? It's quits. If anything enters our bird, that means our bird has probably died. It probably ran into a pipe and got smushed into pieces. Poor little birdie fly high. So we'll do that in a bit, but since our game looks pretty boring right now, we're just starting out and it looks pretty boring, I'm going to give a main game screen. So I'm going to make a main scene. In every 2D game, and I repeat this 2 times, in every 2D game, you absolutely need a game scene. A game scene is where you put all of your stuff in. So you'll have a different bird scene, you'll have a pipe scene, you'll have maybe a ground scene if you want. But your game scene will be one, which will contain everything. You can have multiple game scenes if you want multiple levels, but Flappy Bird only has one boring level. So I'll go to scene on top right here and click on new scene. I'm going to start my root as 2D scene this time instead of other node. And I'm going to name this 2D scene as main. Oops, not a main hash, a main. Let's drink some water. All right, as soon as we create this main game scene, we're going to save it. So this is a good habit, always save your scenes. Now, I want a ground and I don't want to create another scene for a ground and import it, so I'll just simply create it right here. So Control A, remember the shortcut, and I'll create a ground like so. Oops, it's not called a ground, it has to be a body. So every node has a name and you use different kinds of nodes for different purposes. For just a static ground that I want on my screen, I'll use a static body 2D. Now there's a difference between area and body. You use body more when you want collisions with it. You use area more when you just want to detect collisions. So if I'm building a platformer, I'll be using bodies more. If I'm just building Flappy Bird where I need to check collisions, I'll be using areas more. So you'll notice that my bird is actually an area and not a body. But my floor in this case is going to be a body. I'm going to rename this to be ground, like so. And right now the body is, well, actually nothing. You really can't see it because it doesn't have a shape. That's right. Every single node, you need to add a shape. We're going to add a colorful rectangle, so a color rect that we can fill in. I'll change its color to something greenish. Let's look at something green. That looks like a good green color. And I'll zoom in right here and I'll set it to the bottom of my screen like so. So you can hold down shift to snap to your axis and then drag, and you can zoom in a bit. It doesn't have to be exactly perfect, but it looks nice if it is. So like so. And our game now has a bottom screen. So at the bottom of your game, you'll see a green rectangle, right? You all still with me? Okay. So after we've done this, what I want to do is finally talk about collisions, and I'll add a collision first. So a collision shape 2D, and a collision is basically this rectangle itself is literally nothing. It cannot interact with anything inside this game. It doesn't know when other things are entering it. It doesn't know when anything is hitting it, or in this case, it doesn't know if our bird has flown straight into the ground. For that purpose, you need a collider. And we're going to use a collision shape 2D. By default, it doesn't have a shape. We can click on the shape right here and then give it a rectangular shape. So there's different kinds of collision shapes that you can keep. I'm giving a rectangle in this case. So I'll move it up here, right? And I will move this collision to cover my ground. It's pretty satisfying, right? So now I can finally check. This collision shape 2D gives me some signals. Signals means it gives me some stuff. You can see draw, hidden, tree exiting, tree entered. It gives me a lot of stuff to figure out if something has entered my body, so entered this collision area, or exited this collision area, or properties about anything inside this collision area. In this case, we just want to detect if our bird has flown into this collision area. That would mean the demise for the bird. Okay, so we've created the grounds, and let's drag our bird into this scene. So all we need to do is select the scene. We're in the scene. And then our bird from the bottom right here, I'll just drag our bird in. And you can see our bird is now in the middle of our screen. If you want to change the shape of the bird or the size, you can actually make it a little bit bigger here. And let's delete this out. And let's re-add our bird, and it's going to be slightly bigger. Or you know, you can use the transform and then increase the scale to be slightly bigger from the node. So I think our bird was a bit more perfect as it was. Okay, I'll edge it to a little bit left of my screen. I'll start it over here. Let me drink some water again. A lot of water. My throat is getting really coarse. Okay, left of the center, you want your bird right here, and then this is how you start your game. Now let's start the scene. If you press F5 right now, you're going to load into your old scene. That was the one where we just had our bird and no floor, no nothing. Well, how do I set my main scene to be my main scene? Well, you go into project settings, and under your run, you reset this. And then now let's select our main scene to be our main scene. Let's start this up. And now we can see it is now the scene that we originally wanted it to be. You know, the scene with our ground and stuff. But still, when we collide with our ground, we just go straight through. We're not dying, we're not pausing the game, we're not doing anything. So we want to be pausing the game if we're going straight through the scene like so. Also, the background looks kind of ugly with this dark gray. Let me see if I remember how to resave that. So I think it was rendering, and under environments, okay, default clear color. You can change it a bit over here. Let's set it to something more lighter, something that looks more like a sky. It is a bit distracting to edit in though. So let's look at how that looks. It looks pretty fine for a Flappy Bird game, right? But let's not set it to that right yet, because the actual game scene looks a little bit disturbing. Yes, water is very good. You should drink a lot of water. Don't get kidney stones. You'll have to piss them out and it hurts a lot. Okay, so aside from the gruesome bodily facts, we have our bird, we have our scene, and we have our floor, right? So now let's go into our bird. Actually, let's go into our scene and then create our main script. So under my script, I'm going to create a main script and then put this inside the scripts folder as we did before. Oops. Scripts like so. And again, we get a bunch of functions. Right now, we don't need any of this. So our main handles our entire game itself. And our game needs a lot of variables to work. One of the main variables is we need to know if the player is alive or the player is dead. So we're going to create a variable called var is alive, and it's going to be a boolean called true. And we're going to create another function called game over. And this is going to be called every time we die. So anything that can kill us is simply just going to call this function and then be done with it. So collider, this collider right here, as soon as it detects the player is touching it, it's like, oh, hey, call game over. And our script handles all of it. Our pipes, as soon as our pipes touch the player, it's going to be like, oh, hey, call game over. And then the game over is going to handle everything. So inside game over, first of all, we need to check if is alive. We don't want to keep triggering game over even after our player is dead, right? You don't want to keep shooting a guy after he's lying there unconscious in his own pool of blood. Kind of gore. So we're going to set is alive to false. We're going to set, I hope I don't get cancelled. We're going to set is alive to false. If we're alive, now is alive is going to be false. And for now, I'll just print out game over. Simply just print out game over, and I won't do anything for now. Actually, another thing that I do want to do is actually get tree dot paused equals to true. So all this is going to do, get tree is going to get a tree that has all of our nodes. So our main scene has a lot of nodes, right? It has our main ground bird. It's just going to pause everything. Dot pause is going to set it to true. Simple as that. Let's save it right now. Right now, we won't see any changes because this game over has to be called manually by us. Notice there's no underscore in front of it. Anytime there's an underscore, it means that GoDot engine is automatically going to call that function. If it doesn't have an underscore, it means you have to manually call that function because you created it yourself, most likely. So inside our ground itself, we should now start to print game over. Well, we're going to do that by simply going into bird. And you can see currently our bird just has a shape. Our bird does not know when it's colliding with something. Our platform knows when it's colliding with something because it's got a collision shape 2D that tells it, oh, hey, we're colliding. But our bird just has a polygon 2D that won't be able to figure out why we're colliding or where we're colliding. So for that, if you make a wild guess, yes, we need to add a collider. But there's a lot of collisions, right? There's a collision shape 2D, and there's the collision polygon 2D, a lot of 3D collisions, all of this. So collision shape 2D gives you your basic shapes. Like if you have a triangle, if you have a circle, if you have a rectangle, using collision shape 2D is your go-to. But our bird is, well, a weird looking shape. So we're going to use collision, oops, not node 2D. We're going to use collision shape 2D, polygon 2D. So using this polygon, we can now draw inside our bird. So let's add it one more time, and I'll click on my bird and I can simply outline, my bird like so. So now I've created a collision box around my bird. And now every time that this collision box is going to touch this collision box, we know that we can detect it now. So now finally inside my bird script, I'm going to go into my scripts. So the bird GDScript that I had right here, and I'm going to write a function called on body entered, and it's going to take a body. And inside here is going to call the main scene. So I'll drag this main right here. By the way, you can do this. So inside my bird script itself, if I want to reference anything, so if I want to reference this ground and do something to the ground, then I'll pull the ground in. If I want to do something with this collision shape, I'll pull it in. So I'll just pull the bird in. And as soon as I pull, not the bird is literally itself. I'm going to pull the main in. As soon as I pull the main in, I can call its game over function. Like so. So basically what I'm saying is this bird has a collision body right here, this collision body. And this collision body gives us a property. Actually, it gives us a signal, and the signal is called on body entered. So this body has on body entered. So you can actually connect this right here. You can connect it right here. So let's disconnect it. So this signal, disconnect it. Body entered, you can connect this signal to our bird. And as soon as we enter, as soon as something enters our bird's body, then we're going to call that dot game over function. That should be pretty simple. Now in our main scene, let's go ahead and look at our main script and let's figure that one out. So our main script has a game over function and our bird script has a on body entered function. Right? I think this will work, but it may not work out because we may not have connected the body entered signal correctly. So let's see. Let's start this game. And let's just jump around for a bit and then let's fall down. Yes, we do get game over. So thank God. My heart almost dropped, but it does say game over. So basically what happened was a signal is, well, an event, for example. So you can literally read it right here and know what a signal is. Like for bird, you have a lot of signals. Since it's an area, you have a signal for area entered, exited, shape entered, shape exited, whatever, mouse entered, mouse exited. So like hovering over it, you can check it as well using collision object 2D and stuff. But what we wanted was body entered. So emitted when the received body enters this area. Body can be a physics body 2D or a tile map. Tile maps are detected if their tile set has collision shapes configured. Requires monitoring to be set true. Now we'll work with tile maps in actual full course video that's coming out on Coded. Don't miss it. I think it's coming pretty soon, actually, a few days from now. But right now we're not working with tile maps. So we call the game over function because our bird is colliding with this rectangle object on main right here. And that is simply what's happening. I know I'm over explaining things a little bit, but to those who are new to all of game development, it's probably helpful as hell. So game over right there. Now, what do you think this game is missing? Right? It feels like this game is pretty much complete. I think we should wrap up. No, this game is missing the damn pipes. That's the whole point of Flappy Bird. We don't have any pipes yet. So we can add some pipes. Let's create some pipes. So we can add it in main itself, but that's not what I want to do. I want to create a different scene for pipes. I'll create a new scene right here. And every time that you add a new component to your game, you're going to do this. So if you add an enemy, if you add coins, whatever in Flappy Bird, I don't know why you would have coins, but if you want to add coins, then you create a new scene for coins. So I'll create a new scene for pipe. I'll start with my node 2D and then call this pipe. And again, since pipes have shapes, I'm going to add a static body. So a static body 2D like so. And then I'll call this top pipe. Top pipe like so. And of course, this is obviously going to have a rectangle, which is colored. Not only that, it also needs to have a collision. Now you understand why you need collisions. So a collision shape 2D. So let's get our color rect first. I'm going to get this, and all I'm going to do is I'm going to extend it by a lot. Like, it needs to be really big. Now note that not all of this is going to render onto your screen at once. Your screen is only going to see up to here. But what if this rectangle needed to spawn down here? It can do that because it is very long. So it's not going to cut out. If it was short, it will cut out. So I'll create it like so, and my collision shape 2D itself. Oops. My collision shape 2D itself needs to have a shape. So I'll go into my inspector, select my collision shape 2D, and instead of empty, I'm going to use a rectangle shape 2D. Now there's a rectangle in the middle right here. I'm going to pull this rectangle and I will attempt to cover my entire rectangle with it, my entire color rect with it very efficiently, like so. I know there's probably a shortcut out there for this, but I haven't learned the shortcuts yet, and I think this is pretty useful. I'll look them up and let you know if there are some easier shortcuts to do this, but I feel like this would be faster anyways. We've created our top pipe. Now click on it and you can right click and click duplicate, or you can click on it and press Ctrl D, which is going to duplicate that entire shape bottom. And then just name this bottom pipe. Now you'll try to go ahead and move this bottom pipe, right? But then you'll notice you're moving your collision shape and this individually, and you're moving all of this individually, and it's a whole mess. So what I would recommend you do is the one that you're not moving, just hide it. So click on the eye on top pipe. You've hidden it. Now select everything that you need to move, hold down, drag it, hold down shift, and then just drag it down. And then unhide your top pipe. Simple as that. Remember, if you're holding down shift, then it's going to move parallelly, so it's not going to let you move outside. Even if I'm moving my mouse like this, it's not going to let you move outside. So these two are fine, except I forgot to add a value for my color rect. Let's make it a green. I think it's a little bit of a lighter green, like so. And I'll copy this hex code and I'll put that hex code in right there so that both of them are consistently the same colors. And now save your scenes. We're going to save it as pipe, simply as that. Another thing that these pipes need to have is, well, we need to know when a player scores, right? So for example, in our main, let's just pull in our pipe right now. Let's pull in our pipes like so. like so. And then let's start our game. If you do collide with the pipe, oh, you cannot collide with the pipe because we're not moving forwards. So let's actually move our pipe towards the player like so, just for demonstration. So you'd have something like this, and the player moves forwards and then the pipe moves left. But you can see as soon as I touch the top of the pipe, it is game over. But how do we actually know if player scored a point? Well, you know player scored a point if player passes through this without hitting anything. We got the hitting part down because as soon as we hit something, well, it's game over. But how do we know if the player passes through? Well, we do that by adding another collider in between these pipes. So we'll add a thin collider between these pipes. And if the player has collided with it, then we'll say that the player has scored a point. Okay, so in our pipe scene, I'm going to add another area, just an area. I'm going to add an area 2D. And this area 2D is going to be named score zone. Right? And inside it, I need a collision shape. So collision shape 2D. And this collision shape 2D is going to be a rectangle. It's probably going to spawn up top right here. Let me drag it all the way down. Move around right here. And then let me position it right here like so. Don't touch these edges. Just place them like so. I think I got it bang on the first try. And this should be really, really very thin, because the player shouldn't be able to score a point just by barely going inside the pipe. You know, they should be actually committed to the pipe, move a little bit inside the pipe to actually score a point. So I'll move this slightly right. So if they reach towards the edge of the pipe like so, then they score a point. Now we actually need to check that as well. So we'll add a script to our pipe. Let's add a script like so, create a new script, save it under scripts, and inside it, we'll just delete everything. There are a few things we need. The first thing is a constant speed. This is the speed at which our pipe is going to move through our screen. Let's set it to 150.0. So our pipe is going to move from right to left at the speed of 150 pixels. Then we'll create a function called process, and it's going to take a delta. This is not a function that we created, but it's more of like a function that already exists. You know, it's going to run every single frame like any other script that we saw right here. So bird, you can see that process is going to be called every frame. It's just that process function. And what we're going to do is position x is going to minus equals to speed times delta. So if we did plus equals to, our pipes would move towards the right of our screen. We want it to move towards the left. So minus equals to speed times delta. And another thing is if position dot x is greater than minus 100. That means if we've gone past the edge of our screen, then q underscore free. Now this is very good for optimization because, for example, you have 100 pipes that keep spawning on the right and keep going left. Right? Like in your main scene, you have 100 pipes that keep spawning on your right and then go left, they go left, they go left. At the end, you'll have a lot of pipes on your left and more are coming from the right. So what you want to do is as soon as your pipe exits the scene, the player can't see it anymore, we just make it go away. We free the queue, that means we delete these pipes. And a new sets of pipe will come and they'll go off the screen and they'll also get deleted. So the logic is pretty simple right there. And of course, you can make this game easier or harder based on how high or how low you place the pipes. I'm placing a decent gap between the pipes because I'm really bad at Flappy Bird. And I feel like if I don't do this, then I won't be able to properly demonstrate my own game. Right? So after we've done all of this, let's save all of this. We still need our score zone wiring. So let's go into our script. But before that, let's try running our game just to see if it works. You can see as soon as our pipe is too much to the left of the screen, it automatically disappears. Now I think 100 is actually a bit too less because it's disappearing while I can see it. I can see it disappear. Let's make it 150 so that now our pipe is moving towards the left of our screen and then it disappears eventually. I think 150 is still visible. Let's set it to minus 250. I think that's what I originally intended to type out. So I keep moving and then it goes to the left of my screen and by now it probably has already disappeared. We can actually print out a statement right here and say pipe disintegrated. into atoms. And let's run this game. And we should see that eventually when pipe moves too far to the left. Okay, so as soon as we moved off the screen, the pipe was removed. Simple as that. That saves us some optimization issues. Now, inside pipe.tscn itself, we're going to select our score zone. And over here, a lot of signals will be unlocked. So pipe has different signals. Top pipe can give different signals because of its collision shapes. Canvas item node. Bottom pipe can give different ones. But score zone, since it's an area, it has a few extra properties. And what we want is body entered. We're going to double click body entered, and then we're going to connect it. As soon as we connect the signal is going to show up right here. Basically, every time the score zone sends out a body entered signal, our pipe is going to handle that code in here. All we're going to do is we're going to get our main, and inside our main, we're going to dot add point function. We're going to create a function that adds points. And the other thing that we need to do is the score zone itself. So we'll pull in the score zone dot monitoring equals to false, because monitoring means it's checking whether something is colliding with it or not. If you turn monitoring false, it's going to stop checking collisions. Since we've already collided with this score zone once, we don't want to collide with it again. So by some bug, maybe if somehow, we went through it and then somehow we collided with it again, that single point, that single slice would give us 2 points. So we don't want it to do that. That's why we do score monitoring equals to false. Now inside your add points, we actually need to implement this function inside our main. So I'll create a func called add point. And inside this add point func, all I want to do right now is print score. And let's start the game. And hopefully this works out. So I move to the right and it does not. I wonder why. Let's go inside our pipe again. And on zone body entered, let's print out scored. I have a doubt that this function is not being implemented at all. Let's go ahead. Okay, we're not actually colliding with that at all. So let's see what happened. In our pipe itself, we have extends no 2D. We have a speed of 150. Our function is a process delta. We're moving and we're freeing the queue. That's pretty basic. And our pipe roots we're saving as pipe.gd and our score zone wiring. So we went to our score zones and in our signals, we got the body entered signal. And this has a collision shape. So the collision shape 2D, maybe it's a little bit too thin. Maybe I made it way too thin. Maybe a little bit thicker all the way over here. So as soon as this collision shape 2D is entered, once we enter it, then we're just calling add point, and we're calling this scored as well. Since it's a child of the same pipe scene, this can generate into pipe.gd. It can connect its own body entered signal. Does this have a body entered signal? No, it doesn't. Does our collision have a body entered signal? No, our score zone has one. Let's try this again. Maybe the score zone was just a little bit too thin. Nope, that was not the case. Let's keep going. We'll fix this bug in a bit. In our add point function itself, let's just keep going for now. Inside our add points, we'll just add a score variable and we'll increase it by 1. Up top right here, we're going to create a var called score and then by default set it to 0. And inside our score, we're going to have a score label. So any text that you want on your scene is going to be a label. So let's start a label like such. Insert that label. Let's rename it to score label. And then we're going to pull it in here. Right, so dot text equals to string of score. Since this text is a string, we have to actually convert our score numerical value into a string value to be able to use it. Right after then, we're going to get our tree. And then, nope, right after then, we do nothing because we've added a point, we've added a score, and then we should move on. So by default, let's go to our scene and our score label. Let's go in here and then let's say 0. Let's see how that looks. It's a bit small, it's to the side of the screen. Let's pull it to the middle. So we'll make it a slight larger. We'll pull it to the middle of the screen. We're going to horizontally align to the center, vertically align to the center, like such. That should be fine. And in our theme, you want to go to your font size. So in your theme overrides, in your font sizes, let's check this and set this to something like 50. Once you set this to something like 50, it should be slightly larger and visible on our screen. The only problem is that our score is not updating. This is also slightly towards the center like so. And in our pipe, I actually really want this score feature to work before we move on. So let's go from the very top right here. We created a new scene called pipe. Right after that, we added a static body called top pipe, bottom pipe. That should all be fine. Then we added a child called score zone, which is positioned in that gap, which has a thin collision shape 2D that is covering that gap. And then we save this as pipe.tscn. Simple as that. Then next in our pipe script itself, it's extending node 2D. We have a speed for it. Then in our process delta, our position X is moving through that speed and is freeing the queue. And then for our score zone wiring, all we did was went to our score zone. We're inside here and it's node tab. Let's try to connect this again. So our body entered, generate into pipe 2D, connect its own body entered signal into pipe. So once we connect it, it offered a on score zone body entered or similar as that. And we did all of this. So we adjusted this path. We adjusted this path to be the same and everything should be the same. Let's start it. We're still not getting it. Let's take a small quick break. I'll be right back. I'll go to the washroom real quick and we'll continue right where we left off right in a bit. All right, I'm back. Hope I didn't boo everybody off. So let's go ahead and look at this problem again. And I actually realized something while thinking about this. So we have our on zone body entered right here. But our bird itself is not a body. And I've said this multiple times and forgotten myself. Our bird itself is an area. It is not a body. So we don't need a on score zone body entered. We need actually an area entered. So I'll cut out all of this. And let me free this. Let me disconnect that node. And let's disconnect that real quick. And instead of body entered, we're going to do area shape entered. So on score zone area shape entered. Actually, I'm not sure if that was the exact correct node. Let me look at this. Maybe this is just an area, like so. Let me look it up real quick. Oh, there it is at the top right there. Let's disconnect this, let's disconnect this, and disconnect this. Let's connect the area entered, on score zone area entered. We can cut all of this out. And inside here, we can paste that code that we had earlier. Now, if we run our game, then we should now see that our score is actually updating. We get scored and our score has now updated. That should be pretty simple. It was just a matter of using area instead of using body. Now we should procedurally generate these pipes and we should be done with today's stream session. So in my main scene, I'm going to delete this pipe right here. So I'm going to delete this node pipe because we're going to generate that automatically now. So in main, I'm going to add a node. I'm going to add a plain node 2D and I'm going to name it pipe spawner. Pipe spawner. And I'm going to add a timer under it. So this pipe spawner is going to have a script. So under my inspector, I'm going to add a script under my scripts. And I'm going to exit all of this out. And I'm going to import my scene in here. So I'm going to import my scene like so. And to load it in my home, I'm going to const pipe scene, which is going to be my variable name that's going to load this screen. And it's going to be preloaded. So we load it as soon as the game starts. And we have another function called onTimer timeout. So inside my signals, I can pull this timer function, connect it to my pipe spawner. And as soon as we time out, so as soon as those timers time out, var pipe equals to pipe scene dot instantiate. So we're going to create a new pipe scene as soon as that timer runs out, and I'll show you when it does. Pipe.position equals to now vector2 is going to always start at 500, but the x coordinate, the y coordinate up or down is going to vary between 150 and 450. Right after this, we're going to get the parent and dot add child, and we're going to add the pipe to that child. So now when we start this game, we'll see that from the right, as soon as the timer times out, it doesn't currently because we haven't set it to do that. Set this as auto start, and every 1 second, the timer is going to time out. So now when we start it, every 1 second from the right, we're going to get a pipe like so. Oops, the pipe is way towards the bottom. So let's go to our pipe and 2D scene. Let's move our entire thing a little bit to the top. So a little bit higher like so. And let's start it. Let's see how that looks. It's still a little bit to the bottom. Hold on. It might be some error in my script itself. I did take a range of 150 to 450. I did take a vector2 position of 500. Let's see. Maybe this position needs to be a little bit higher. Oh, it went slightly lower. So maybe this position needs to be around 200. Nope, I don't think that's it either. I'll be right back. I'll fill up some water. All right, back with some more water. Did you all have any questions by the time I left? I think not. All right, so we did make our game and it does seem to slightly work, but there is a problem. And the problem is that our pipes are actually spawning pretty low. So I haven't actually faced this problem before, and it should all be working fine because my pipe position should be instantiating at 150, 450. Let me look up my reference code on my other monitor real quick. So we're extending node 2D. We have a constant called pipe scene that is preloading our pipe scene. Let's see if there's anything wrong with the scene itself. It seems to be fine. It seems to be pretty fine. Shall I move all of this to the middle of the screen like it was earlier? So right there. And next, let's look at the script again. On timeout, so on timer timeout, we're spawning everything right. That should be fine because in our main scene, as soon as you look at our timer, our wait is 1 second. So every 1 second, actually, let's put this to 1.6, or you can leave this at 1. At that second, the timer is going to reset and it's going to call this method. Again, after 1 second, it's going to reset, call that method. Again, after 1 second, it's going to reset and call that method. So that should be going on fine. Whereas var pipe, we're instantiating this scene. Then pipe.position is a vector2 that has to start at 500, which is an x position at the very right. So it's starting at the very right of our screen and then moving towards the left. So I think we need to tweak these two values, which are changing from the XY coordinate. Let's see right now, it's moving far too much to the bottom. Let's see. It's moving far too much to the bottom, so it's going to spawn a little bit higher. So our range, let's increase our range by, let's say 300 on each side. So 350 to 750. And let's see how that looks. oops, I think I had a negative effect. So we need to decrease it. Let's say minus 150, and then decrease this by 300. So 150, minus 150 to 150. And there we go. It spawns a little bit higher. And if you notice, the poles, they're spawning in pretty quickly. They're spawning pretty close to each other. That's because our timer is too less. Let's set our timer to something like 1.6 and then restart this game. So when we set it to something like 1.6, now when we play the Flappy Bird, it actually feels like a Flappy Bird game. Although still, it feels a little bit too close. Later, you can change your timer speed to make the positions spawn in faster, to make the positions spawn in slower. But right now, we're spawning 1, and then we have 2. We're gonna move a little bit up. Let's get a 3, 4, multiple points like these. And of course, you would make these gaps smaller to make the game more challenging and actually have players have difficulty beating the game. Also, all these debug lines that you're getting on score right here, let's see, we're getting score right here, right? Let's remove all of this. So we don't want to be printing out everything all the time. Even for game over, I don't want to be printing this out. For game over, I actually want a different game over scene. So for that scene, let's actually go into our main. So most of everything that you do will be inside your main, relating to your game. So restarting the game, ending the game, adding points, it's all going to be inside your main so that you know where to keep track of things. Only things related to the pipe are inside the pipe, by the way. So inside our main, let's add an func and let's check for input. So we did this before. This function is automatically going to be run as soon as there's an input on the screen. If not is alive, and let's see, if not is alive and event is input event mouse button. So if not alive and we left click or right click or basically click with our mouse button and event.press, basically click, that means that we saw the game over screen and then we decided to click. It's going to reset our game. So to reset our game, first of all, we need to get tree.paused equals to false. So we have to unpause everything. And then get tree.reload current scene. And now when we start this, as soon as we hit something, let's go ahead and try to hit something like so, our game ends. We had a score of 1, our game ends. But if I left click again, so that's not working. When I left click again, it is not restarting the game. So that is probably because inside our main, there's a property called process. So process has the mode inherit right now. We have to set this to always. So what happens is GoDot automatically ignores mouse clicks, button clicks, your keyboard presses, or anything like that as soon as your game is paused. Since we pause the game when it's game over, in a paused state, it cannot detect anything. But we explicitly set this mode to always. But this gives a bug. I believe it should give a bug. So let's start this game and see what that bug is. So we started off well, then we spawn in, and even after we touch, we've already done game over, but we're still moving. And if I left click, we reset. So that is because we're not pausing anymore. We're always listening for processes. But only our main should listen for processes because our main is, looking for key presses to restart the game. But the rest of our game should pause once we hit game over, right? So specifically in our bird, I'm going to go into processes and I'm going to give in pausable. Inside our pipe, I'm going to go into processes and I'm going to give it pausable. So our pipe and bird, both of them don't move when our game has ended. None of them can move. Now, if I start the game, you'll notice that the pipe and the bird itself can be paused, but the main scene cannot be paused. So everything else is paused. Our pipes, our player, everything is paused, but the main scene can still listen for key presses. And now when I click, then we're listening for key presses and we restart the game. But we don't really have anything that says, game over. Right now, it's just you start playing the game and then at the end, you hit something and then the game just abruptly pauses. So we need a game over scene. Let's create a game over label in our main. Let's create a label, L-A-B-E-L, label, and let's call this game over label. And in this label, let's go inside our 2D and see what it looks like. Let's bring it more towards the center. Oops, bring it more towards the center, drag it right there. Like so. Okay, and let's actually increase its size as well. And type in here game over. Click to restart. And let's center this, horizontally center this, vertically center this. And the color is, or the size is pretty small. So I want the size to be slightly bigger. I'm going to go into theme overrides. I'm going to change the font color to be, you know, a very light or very dark yellow. And my font sizes, I'm going to change the font size to be 50 pixels again. Is 50 pixels too big? Maybe. Let's not set this to 50. Let's set this to something like 40. Okay, so this is something like 40 pixels and leave it right there. Now, if you just run your game, what you'll notice is you keep getting game over. We only want to show that when the game is actually over. So inside your main script, let's go into our scripts and let's go into our main script. You can actually pull this label in right here. And what I can do is I can pull it inside this game over function. So this is when we're doing game over. I can do this dot show. So as soon as it's game over, I want to show this message. And by default, it is going to start hidden. So I can click on this eye icon and I think it will start hidden by default. I also want to hide it when we restart. So I'm going to copy this line of code. This is our restart code. So I'm going to give it .hide. Let's label this. This is our restart code. Now let's run it. Oops, I cannot have a double slash restart code. And it is actually a hashtag because it follows Python norms. So I'll keep going. And after about 2 seconds, I should start seeing pipes. And I'll hit something and I'll get game over, click to restart. And when I click, that game over scene goes away automatically. Does that label come over my pipes? Let's check. I think this label actually goes behind my pipes. Let's try going to a pipe that might intersect with my game over label. So this might. So you can see that this pipe actually spawns in front of my game over label because this pipe has higher priority. How do I lessen the priority? Well, we're spawning the pipes using pipe spawner like so. So lessening it with code would be quite problematic. So what we can do is we can increase the priority of game over label so that it shows above other labels. So I can go down here and click on ordering and I can increase its Z index to something like 20. I also want to increase the Z index of my ground. So I'll keep it at the very bottom right here. Keep it at the very bottom right here. So the lower it is, the higher it is going to show. Let's start this up. And as soon as we hit a pipe, I don't think I want to hit this one. I want to hit one that will actually intersect with my game over. So I'm looking for a pretty low or a pretty high pipe. Seems like I'm getting everything in the same region. Oh, there we go. So you can see that the game over text actually spawned above my pipe this time. And when I collide with the ground as well, my collision is behind the ground and not over the ground itself. Maybe you want it over the ground. If so, then keep your bird below the ground itself. And the score, I feel like the score is slightly too high. Let's set the score to be a bit lower. And I don't think the center actually centers it perfectly because the left and right don't seem to be centered at all. Let's start this up again. And maybe that's a little bit more towards the center, but maybe a little bit left. Yeah, I think that's more towards the center. So now you have your basic Flappy Bird game. Let's actually make the pipe gap a little bit smaller so that it's actually, you know, challenging. Let's set this collision body to be a little bit smaller. Let's pull the collider rect a little bit lower. So the top pipe itself. Oops. The collision shape 2D of the pipe should be a little bit lower. The color rect. Can't modify anchor offsets when the parent has a side of 0. Disable anchors mode in the toolbar. So the parent has an anchor. I don't see where the anchor is. Let's go into collision shape 2D. Let's go into color rect. The layout. It shouldn't be having an anchor. But let's just move it a little bit down, I guess. So let's move it slightly further down. Up to there, I think is suitable. And then let's move this collision shape over it. And let's start our game so that those gaps are slightly tighter. I fear that the gaps may be too tight. Yep, I think the collision shape isn't, would you look at that? You see this collision shape, it's way too high. So even though we didn't actually collide with the thing itself, it still collided with the collision shape. So let's go over that again. And of course, you can make your bird smaller as well so that this game is a bit more challenging. And yep, I think this is a bit more like Flappy Bird because you actually have the chance to lose. So although it seems like I'm doing very great right here, still when I hit something, it's going to do that. Also, another thing that I noticed is that the pipes are spawning over the ground. I want them to spawn under the ground. So I'll go into my main and then the ground itself. I'm going to change its ordering as well. So I'm going to put its Z index to something like 20 as well. And now when I start it, then I should get that the pipe is spawning behind the ground. No, the pipe is still spawning above the ground. Let's save this. Let's increase the Z index to something much higher. Maybe the pipes are just overriding that value. So you can see now that the pipes are spawning behind our actual ground. Now, of course, there's a lot to this game that needs to be added. We can add a home screen with Flappy Bird in it. The other thing is we can add, of course, sound effects because you want sound effects when you click on the bird. Another thing is you can add the actual animations and the sprites for all of these items. So we just used rectangles right here. For the ground, we used a solid color. And for the bird, we just used a yellow looking weird triangle. And the very first thing that I did right here, putting the default color, I actually want to do it right now. So what you did was you go into project settings and then you go into environment under rendering. And you'll have this beautiful blue color. You can use a sprite or a canvas, I believe it is, for this purpose as well, but I think blue will do just fine for now. And like so, I think the pipe colors need to be slightly darker. So something like that. I'll copy this pipe color and in my other rectangle, I'll simply just paste it in. And let's start it up. And you should see that the pipes are a bit darker, right? Maybe a little bit too dark. But all that seems to be fine. Is the score going behind the pipes? It is. The score is moving behind the pipes. So our score itself, the score label itself should also have a very high Z index. So the higher you do your Z index, the more above the screen is going to show. Now, of course, you don't need to put it at a ridiculous value like 183. But I'm just making sure that everything's going to spawn above. And that is your basic Flappy Bird game done. Let me know if you really want me to put in animations and all the sound effects, and we'll go ahead tomorrow and then polish everything up nicely. So make this into an actual finished game, and I'll also show you how to export this so you can play it as an executable on your device. And then actually share an exe file to your friends and they can play this exe file. Maybe we'll add a system that can save high scores and stuff so that you can be a little bit competitive with your friends as well. So that's all for this stream. That's all we're going to do in this episode of GoDot. There will be a video coming soon. In that video, we'll be doing a lot more advanced stuff. We're working with tile maps, tile sheets. We're working with the actual assets, sounds, buses, a lot of nodes, scenes, and everything. And I'm sure I'll add some visuals in there as well so that you better understand how nodes and scenes work. So there'll be some motion graphics for that. And we're all done here for today. So if there are no final questions, if any of you would like to ask me something, otherwise I think we will end the stream. All right, it's been a pleasure, and I'll catch you tomorrow, or I'll catch you in the next video.